Okay, here we go. Synthetic division. Now, if you did whatever I gave you, I don't know, 8, 9, 10 problems, I gave you that many problems, you did long division that many times, you probably thought, wow, there's got to be a shortcut to this, and there is. It's right here. It's called synthetic division. If you want to call it this word, go ahead, because it might put a smile on your face. Short division, meaning short, quick, easy. Okay. Now, read this paragraph with me, but do me a favor. When we get done reading the paragraph, let's do 2 problems together. Then go back and read the paragraph, because the paragraph will make more sense after you've done these 2. All right, synthetic division simplifies long division process for dividing by a linear expression, x minus a. So what are you going to divide by? No. The big word was, you're going to divide by what?
Linear.
Linear. Now linear, if your divisor is linear, it looks like this. X minus a, let's talk about x minus 3. Or maybe x plus 4. If you're dividing by linear factors, use this method every time. And linear means x to the first, x to the first. What you can't do is divide by what? Quadratic. If I said divide by quadratic, you can't. Not when it comes to synthetic.
What about like cubic?
Cubic, no. Quadratic, no. Just what?
Linear.
Just this word linear. Okay?
So like the cubic ones, you have to do long division?
Yes, you have to do long division. Yep. And by the way, I think on the test, it's going to say, and I'm pretty sure it does, this problem, do it long division. So you're kind of forced on the test to do it the way they say to do it. Okay? You can always, if it's a linear divisor though, you can always check it with synthetic. That's kind of nice. Okay, what else does it say? To use synthetic division, write the coefficients, including the zeros of the polynomial in, that's supposed to say in, that's in standard form. Omit all the variables and the exponents, get rid of them. For the divisor, when you're dividing, just reverse the sign. Use a instead of negative a. Okay. Now, again, I read all that to you and you go, what's he saying? Go back and read it after we're done. You'll go, wow, now that makes sense. Okay, here we go. This is what you're doing. You're going to take synthetic division. You're going to divide this polynomial by this polynomial. If you think back to Friday, on Friday I asked you to do this. Take this long polynomial, divide by what?
X plus 2.
X plus 2. That's what I asked on Friday. But now it's Monday. Now we're going to do synthetic. Take your division bar and turn it upside down, like that. Just go the other way. Go the other way. Okay, I know it's crazy, but just do it. Okay. Now, what they said in that paragraph up above is take all the coefficients of your polynomial, your dividend, write the coefficients only. So what's the coefficient in front of x cubed? 1. In front of x squared? Negative 14, then?
Negative 54. Or again.
51, then?
Negative 54.
Okay. So this is what they said to you. Just do it every time. This is synthetic. Then on the outside, this is your divisor. And what you're dividing by is what? X plus 2. But what are you going to put here? Put the 0. What would be the 0 of this factor, x plus 2?
Negative 2.
Negative 2. And students get this wrong because they put what here? They put a positive 2 because they see a positive 2. Just put this, think of it, put the 0, okay? Okay, now, here's all it is. If you're good at adding and multiplying without a calculator, this can go so fast. You have to do this every time. Stick a 0 in the corner, lower left corner, stick a 0 there, and then here's the process. It's the same every time. When you go straight down, I want you to add. What's 1 plus 0? 1. Then you take the number on the outside and you multiply. And that's how you do it. You add, multiply, add, multiply, add, multiply. So what's negative 2 times 1?
1.
Negative 2. Put it here. Now come down. What are we doing? Adding. Add when you go down.
Negative 2.
Negative 16. Yep.
Oh.
What? Are you okay with that?
Yeah. I put negative 4 instead of negative.
Next. That times that. 32, yes, 32. Add down. 80 what? 3. Okay. Multiply. Negative 166, yep. Add down. Say again.
Is it negative 220?
Negative 220, you got it? Okay. Now, you're probably wondering why did he put a little box around it or why did he circle it or whatever? Because that number, when you're all done, that last number is always going to be the remainder. Remember, this is division. It's a process of division. So that number is the remainder. The question becomes, what are the other numbers? Oops. What are the other numbers? Well, the 83 turns out to be the what?
Constant.
It's the constant. The negative 16 is the coefficient in front of the what term? The x term. The 1 the 1 turns out to be the constant in front of the what term? What would be next after x the first?
X squared.
X squared term. Okay, now try remember, this is your answer. 1, negative 16, 83, negative 220 is your answer to division. So, if I say that's your answer, come back up here. Remember this? This is your answer up here in long division. You would write what? 1 x squared followed by negative 16 what? X. Guys, is x squared, then x. Negative 16x followed by 83 with a remainder of, I'll put r dot, negative 220.
You don't have to do 20 over.
You don't have to if you don't want to. If you want to, do it. Okay. Now, I just got a really quick question for you. How, on the test, how do you check it? How do you check division?
Multiplication.
Yeah, you take what? X plus 2, what you divided by?
And then multiply by
Take it times what?
what you got.
Your answer was what?
X squared
Minus 16
plus 83.
Okay. But wait a minute. If you took that times that, there's a remainder of what? So you FOIL this all out, and then at the very, very end, you have to do what? You have to subtract the remainder because that was the extra stuff. So all of this will not give you this. But once you subtract 220, you will get this. I should actually make you do that, but time-wise, I don't want to eat up another 2 minutes. So that is how you do check. And some students will go like this. Oh, that's all I got to do to check see if I'm right. They'll do it on the quiz. They'll do it on the test. I mean, they'll FOIL and subtract 220. Okay, next. This is practice. This is just practice. Go again. Do it again. Less me, more you. What's this number out here? 7. Okay. There's probably enough time to let you go because guess what? Some of you made a mistake. Some of you didn't catch this, I don't think. The coefficient in front of x cubed is 1. The next coefficient is 57, but I put 0.
Because there's supposed to be an x squared.
There's no x squared term. Without the x squared term, you got to represent the x squared term. You have no x squareds, you have 57 x's, and you have 56
Constant.
constant. Okay? If you forgot the 0, that's why you're going to get that one wrong. 0 in the corner. 49 and 57 make what? 106, gotcha. 7 times 106 is 742. Add down. And 798 becomes the what? Remainder. Okay, the next number you're looking at to the left of that is called the constant. This 7 is the coefficient in front of the x term. 1 is the coefficient in front of the x squared term. And now, that is your answer you're staring at. So, if you did the long division to this, you would have got, what are we going to say? 1 x squared
plus 7x plus
7x
106 r
plus 106 r what?
798.
Nice.
Good?
Let's keep cooking.
Is it easy enough for you?
Yeah.
Okay, just remember, this only works on what kind of division?
Linear.
Linear. Okay, so this is linear right here. Now this, if I would have said divide by this, how would you divide by x squared minus 7? That's long. You'd have to do long division here. You're kind of stuck doing long on that one. Good? So if you guys, if you truly understand how to do synthetic, you never will have to do long division unless what shows up? X squared. Or on the test, if it tells you what? To do it. Okay. All right. Next up, page 2 today. Page 2 talks about this remainder theorem. What exactly is this? Well, it turns out that the remainder of your synthetic division you were doing has kind of a neat thing about polynomials. Okay, instead of reading this to you, I'm going to go straight here and I'm going to ask you this. I want you to do this problem 2 different ways. One is direct substitution and one is synthetic substitution. Here's your polynomial, x to the 5th minus 2x cubed minus x squared plus 2. This is your polynomial. I want you to tell me what is your polynomial value when x is what? 3. So this says evaluate your polynomial when x is 3. You did this stuff in September. Direct substitution just says take x, put it in. Put it in everywhere you see an x. Okay, I would like you to do the direct way first before we do synthetic. All right, need some help. 3 to the 5th is what? 2 what? 243? Okay. I know this 3, when you multiply is 27. 27 times negative 2 is negative? 54, yep. I know 3 times 3 is 9, minus 9. Plus 2. So I just did each term separately. What's the answer? Okay. Taylor says it's 182. Is Taylor right?
Yeah.
Do you remember chapter 2? This is the first week or 2 of school. When you evaluate functions or polynomials, when you put in 3 and you get out a 182, you actually found a point on the graph. What's the point you found?
3, 182.
Yeah, exactly. You did this way back in whatever, September. Okay, now, here's what they're trying to tell you about synthetic substitution. If you guys want to know what the value of your polynomial is when x is 3, you can also use this, synthetic substitution, which means you do it all over again with the synthetic process, but what goes out here?
3.
Yes, you can't say the 0 because you're not dividing. When you divide, you put out in front the 0. When you just do evaluation, when you want to evaluate your polynomial, if they tell you to put a 3 in, then put a 3 in. And now do it and see what happens.
What if they don't tell you anything?
Well, they'll tell you something.
Okay.
They'll say P of 10, P of negative 10. They'll tell you what to put in. Okay, now try it. See what happens. Just before you go any further, did you do that? Is that what you did? Did you remember there's no x to the fourth and there's no x, so you needed 2 zeros in your coefficient line. You didn't put the 2 zeros in, you're going to get it wrong. So what was the last number?
360.
The last number is what?
82.
Add now. Not multiply. 100 what?
82.
82. Look here. So direct substitution gives you 182, but synthetic, you get the 182, but what's synthetic? This is actually the remainder.
Okay.
If you were dividing, guys, the remainder would be 182. So the remainder actually turns out to be your answer, so you don't have to do the direct substitution anymore if you don't want to. So now what's happened here, I've given you another tool. Now when people say to you, evaluate the algebraic expression, you can say, well, which way you want me to do it? You want me to direct? You want me to do synthetic? You just have more tools in your tool belt. Now, this is how easy it is. The remainder is your answer. So you'd say what here? My polynomial when x is 3 gives me what?
182.
182. So this is what you need to say on the test. On the test, you have to tell me, when I let x be 3, I get out 182. I'm not going to make you do this on the test, but what does it really mean? You found a point. The point is?
3182.
3182. Okay? Molly, is your hand up?
Yeah, I figured it out though.
You got it?
Yeah.
Okay. Okay, this next one, guys, I don't want you to do this. I know you can. You can take your calculator and work this out, but I don't want you to. Do the synthetic substitution method. Get the answer to this polynomial. When x is what? Negative 4, yep. Don't forget that 0. You did not have an x squared term. What's the number that goes out in front?
4.
Yeah, that you are not, this is not division, you're not dividing, you're evaluating the function. When they tell you to evaluate, just stick the number in that they gave you. Okay? Keep adding down every time and multiplying diagonally. This one actually turns out to be nice. I don't think you needed your calculator on this one. Oh, look at there. We got a remainder of?
Zero.
Try it again. Can you look at my numbers. You got negative 1,000 for your remainder? Okay, so look at my work. Did you, hey, Adrian, Taylor, did you guys forget the zero?
No, I put a
I
1 instead of 7.
You put a what?
One instead of.
No, negative 7.
Oh, right here? Oh, yeah, that will get you every time. Okay, so guys, you know, as easy as this kind of looks, if you multiply or add wrong, you will get it wrong. So what's it say? My polynomial, when I stick in what number?
-4.
I get out what?
Zero.
Which means it's just a point.
Zero.
It's just a point on my graph.
Zero.
Point is, the point coming out of this function is -4 goes in, 0 comes out. It's just a point. Hey, guess what? What? It's the x-intercept. Which means that number is what?
Zero.
It's a 0.
Oh my god.
Which, hey, oh my gosh, is right. Because this is a what? It's a factor. Anybody know the factor?
No.
X what?
Plus 4.
X plus 4. So guys, by finding a 0, you can tell me if this is a 0, then this is the factor. So you already know a factor of the polynomial that was given to you. Okay? That's pretty important stuff as we move on. Okay? You need to know when you do find zeros, you're also finding factors. Okay, here's the deal. I'm done. Now, here, I need to ask you something here. I'm not tell you something. I am not scheduled a quiz in this chapter, so I am going to be giving you homework quizzes. I already gave you one last week, another one this week, probably one the rest of the week, because now you know a lot of stuff. I can't let you forget this stuff. If you do forget it, hopefully tomorrow you see what you forgot. What I'm going to ask you to do now is this. Will you do 3 problems for me? The 3 problems are last week's peach, green, and blue worksheet. Okay, really all it is this. It's the 3 new factoring, 3 methods. Factoring, 3 new methods were, who can say them?
Grouping.
Grouping, yes.
Substitution.
Grouping. What? Substitution? No. Isaac, what are you saying?
Perfect cube.
Cubes, perfect cubes. Okay. Oh, by the way, I was not that mean to you. It's mean enough I do this on a Monday, but I did give you the perfect cube formulas. So when you see it, please follow the formula. This should be a nice, easy one for you. Then there was one more type of factor.
This division.
Quadrant.
I don't think you'll remember this one. Quartic factoring, and I want to show you one of these. Remember quartic factoring goes the same as quadratic factoring. If you end up with something like this, let's just say I put an 8 back here and I put a 6x squared in the middle. You got to remember when you factor, take out the GCF. Do you see a GCF?
No.
No. Then you got to check to see if it's your best friend. Your best friend is the difference of 2 squares, not a chance, or a perfect trinomial. Perfect? Yes. Is that perfect?
No.
Perfect cube, not a perfect square. We're looking for perfect squares. Okay, no. So now it's a trinomial with a 1 in front. This should be an easy one. You should be thinking, how do I get this? X squared times what? Okay. Give me two factors of 8.
4 and 2.
Four and 2. Okay.
8 and 1.
Then, hang on. Then you should be asking yourself, am I done? Is this my best friend?
Yeah.
Is that the difference of two perfect squares?
Oh, yeah.
No.
No, that's the sum. These are not, shh, guys, you're talking and you're missing out on things. This is not the difference. This is the sum. Leave it. Don't touch it. Is this the difference of two perfect squares?
No.
No. We're done. Now, if this would have been, let's just say it would have been minus, if it would have been, then of course you got to keep going. X what?
X plus 2, X minus 2.
X plus 2, X minus 2.
And
You know, sometimes you do have to keep going. Sometimes and sometimes not. That would be, yes, you do, but you had a plus. And because you had a plus, don't keep going. You're done. Yes, sir.
Are you recording?
Still recording this. You're going to ask me if I'm recording at the end of the lesson?
Well, I asked you.
No, you asked me in the beginning. I said it. I'm going to.
Your office.
David, you're just right on the ball here.
Are you gonna be here next hour?
I'm always here. Yep. I'm here till
Oh,
4:30.
Are you gonna be here?
Oh, I don't know.
Doesn't say.
You have to find me. I'm a ghost. I just
Okay, well, if you're not in there, I'm gonna go
You can
back.
come back here.
Oh, that's so weird.
Okay. All right, here's the deal. I got 3 problems for you to do. After you get done, hand it in. Go to work on your synthetic. Okay? Yes, you can.
I don't know.